I'd like to share with you an idea I have had after watching Etho's Nexus project and him trying to figure out how to handle having the switches and being able to select an item. Um, Switches, it's 8 different things you have to flip. Uh, on top of that, he has a problem where you have to look at this and you have to remember 01001101 and then 01001101 and like flip the levers that way. And that's pretty difficult. Not that difficult, but you know, this is something he plans on using for a long time. And why wouldn't you want to have a simpler solution? Um, so here's my idea. Right now I have 2 numbers selected. This is one number, one 4 or one nibble, one 4-bit number. Here's another 4-bit number. It can go from anywhere from 0 to 15. This can go from anywhere from 0 to 15. And this is commonly how you write like binary shorthand, is by converting it from four bits into a hexadecimal digit. So 0 is 4 zeros, 2 is 0010. Going down farther, we get to like B, which is 1011, and etc., etc. This is pretty common in the computing world. I guess let's demonstrate it. So if we press 1, it'll light up 1 on the left panel. Then, let's say we want 60110. Lights up that. Then we can repeat by pressing a different number, let's say A1010. Lights that up. And 1100. Etc. You just keep going and make any selection here. You'll notice that it does actually, so like whenever it's in this state here where it has both numbers and I press a different number, so 91001, you're going to see I press this and it's going to light up the last panel, the last bit. And that's just due to something that I haven't figured out that will take more work. I'll explain it later. So there's 3 parts. There's this display panel. There's this selecting the bit section, and then there's a section in the back which actually handles which panel to display on. Let's go over each of these individually. The first step is selecting the bit that you need. Looks kind of complicated, but it's really simple. Lots of repeating parts, obviously. So I use this trick through here to be able to carry signals in parallel. I'm running redstone repeaters next to redstone wire, redstone dust. So here's the general concept. I've laid this out here. There's 16 rows here. Each of these 16 rows represents the bits that I need to select, the bits that need to be lit up as for that number. So 0 obviously needs 0 bits lit up. 1 needs the 1 bit lit up. 2 needs the 2 bit lit up. 3 needs 2 and 1 lit up. 4 needs 4 lit up. And so if you know how numbers work, there's a 1 column, a 2 column, a 4 column, 8 column, and this is in binary. If it was decimal, it'd be 1, 10, 100. It's powers of whatever base you are. And so this just lays out what bits I need to select. At the very end here, I need to select all of them. And you can see some pretty easy patterns here. So for the 1s, it's alternating it's alternating every other 1 I need to select. For the 2s column, it's alternating by 2s, and alternating by 4s for the 4 column, alternating by 8s for the 8 column. So that's what this does here. If we look in here, whenever I press 1, it powers this, turns that light off, turns this redstone torch on, and then powers this line. I'm not sure if I actually need these things here. But I'm going to leave them there because it's working and I'm not going to touch it. Over here, once I get to 2, I run the power past the 1 because I don't want to light up 1 if it's 2. I just want the 2-bit lit. Run it into this block here. This block is powered. Powers this torch, powers this block, which powers this torch. So unpowers this torch, which powers this torch, which lights this line. And then we get that bit selected. And see, this pattern is repeating the whole way down. Now, once I need, like if I need the 4s also lit up, like this is going to be 6, this is going to be 7, because 7 I have 1 lit up, I have 2 lit up, and I have 4 lit up, so that's totals to 7. So here this is 6, I bypass 1, light this block, which also powers the redstone dust behind it, which powers the 4 line. This powers the 2 line, this powers the 1 line, and I continue that the whole way down. Once I get farther down, I can make some simplifications, like here, this is 8, not 8, this is, this is 8, yeah, so this is 8, so I just run it straight down without touching anything except for going into the 8 line. And then this is 8 and 4 is 12, or D. 10 is A, B, C, D, whatever. So I run this down, power this line, it also goes off to power the green line, etc., etc. Once you get down here, it's a little bit simpler. It was this section here that I had the hardest time. I guess after I got down here, though, I already had the system worked out, so it was pretty easy. So then you have 4 lines coming out, the power, or that run down to these panels, and here's the panel section that I was talking about. So I pipe the input into both of these. You can see this line runs, this is the 1 line, it runs into both. This powers that lamp down there. This powers that lamp here. And then I have this locking mechanism. So whenever you put a redstone repeater next to another redstone repeater like this, you get this little obsidian bar, which is acting as a lock. So you can see that behind it here, there is nothing, there is no signal. It's not on. But the output here is still locked to whatever it was whenever this got powered. So if I unpower this, it uses the signal that's behind it. And so I have 1 lock line running through here, which runs through here, locks this one, the red and yellow, comes up here, locks blue and green, and then same thing happens over here. I lock blue and red. This is not blue. This is blue back here. I should have used a different color. Red and yellow. And then it comes up here and locks green and blue. And then I have these little indicators up here to indicate if the number has been, if the digit is set. Because if you press 0, 0, you might not realize, I mean, technically the output is all that matters, but you might not realize if you've entered 2 numbers or 1. So it just kind of helps figure out what state you're in. So that's that section, and then here is the locking section. Whenever you press any button, it powers this line here. This line goes to this little segment here. So here I can simulate this button being pressed. If I press, oops, that's too fast. You can see it powers this little section here. Powers that torch on the uptick. So I get a shorter pulse. Because what I want to do is once all of these lines are lit up correctly with the correct number, I want to give a quick pulse here to quickly unlock and relock all of these lines, all of these outputs. Or I unlock them just long enough to put the signal through. This section here is storing the state. Whenever this pulses, it's going to toggle between this redstone block being on the left and the right. Whenever it's on the right, it's going to power this comparator, which is going to power down this line. Some things happen. So whenever this line is on, it's going to run through here. It's going to get negated, and it's going to leave this off. This should be on right now because it should be locking the state of being empty. But that's a more complex problem to solve because I need a way of just turning these off, and I don't really have that. It's sort of hard. This is why whenever you have a number selected over here, and you enter a number that's going to clear it over here and enter over here, it'll light this up first. It works, it's fine, but it's kind of messy, and I don't really know how to solve that problem without thinking about it more. And then this section over here, ignoring this little block right here, this line comes over here, powers this, and then powers this. Whenever this pulses, it'll allow the input to change. But because I have this section here, actually, does this do anything? I don't think this does anything. This does nothing. That was an idea I had. Obviously, it didn't work out. What I instead used is there's a delay here. So whenever this line gets powered, it'll power this block first, turn this off, and so for 2 ticks, the line will be off and allow that panel to update. The reverse is not true. Whenever this gets unpowered, the unpowered state is going to go here and turn this on. Before going here, it'll be caught in the delay here and leave this. This will still be on for 2 ticks while this is turning on. With 1 click, it'll unlock the line, and with another click, it'll stay locked. And that lets you keep this line's data while changing the second line's data. And this is the best I could come up with. I don't really want to keep working on it because I'm not going to use it. Now, all of this stuff here looks big and bulky, but realistically, you only need these buttons. You can run the button input down underground into this big contraption. Maybe you could even figure out a way of stacking these so that you have like a 16 by 16 grid. That probably won't work. Maybe you can just have 2 rows of 8 on top of each other. So you have everything a little bit closer and a little bit easier to press. And then run those lines underground into the individual compartments that you need here. But anyways, this is what I came up with. I would really like to see Etho implement something like this in his single-player world for selecting items, because flipping levers is boring. This is pretty cool. Thanks for watching.